We're all swimming in this invisible ocean of information every single day. But what if I told you that hidden inside that ocean are secrets? Secrets that can predict hurricanes or completely change the way giant companies operate? Well, today, we're going to grab our magnifying glasses and become data detectives to learn how to uncover them. Just look at this number, 2.5 quintillion bytes. It's almost impossible to even imagine, but that is the incredible amount of data we as a planet create every single day. With everything from our cars to our coffee machines being smart now, we've created a true data explosion. To even try to get your head around that, think about this. Imagine every single person on Earth writing an entire library's worth of books. Okay, got it? Now imagine them doing it all over again tomorrow, and the day after that. It is an unbelievable flood of information, and honestly, the tide is only getting higher. So with all this noise, all this information flying around, how in the world do we find the stuff that's actually useful? How do we pull out those hidden patterns that can help us make smarter decisions? Well, that's the central mystery we're going to solve today. So the hero of our story is the data scientist. And just like any good investigator who's facing a really complex case, they don't just jump to conclusions. Nope, they start by carefully, meticulously examining the evidence. And for that, they have a really powerful investigative process. And this is the perfect way to think about it, really. Before a data scientist even thinks about building some complex model or making a big, bold prediction, they have to get their hands dirty. They follow leads, they poke around, they try to just understand the unique quirks and patterns of the data they're working with. And that detective work, it has a name: Exploratory Data Analysis, or EDA for shorts. Honestly, you can think of it as the brainstorming session for data science. It's all about understanding the patterns, the weird trends, and the little clues in your data before you even decide how you're going to solve the case. Now, every good detective needs a toolkit, right? Something to help them interrogate the evidence. Well, a data scientist is no different. They have a whole set of specific tools and techniques to make sense of all the clues that are hiding in a data set. First things first, they have to figure out what kind of clues they're even looking at. Data usually comes in two main flavors. You've got your quantitative data, that's all about the numbers, things you can measure, like sales figures or temperature. And then you have qualitative data. That's more about characteristics and descriptors, things like colors, names, or different categories. So what's actually in this toolkit? Well, the key tools for EDA are visualizations, like charts and graphs. That's kind of like dusting for fingerprints in the data. They use basic statistics to quickly summarize the scene of the crime. And they use pattern recognition to start connecting the dots and finding those hidden relationships between different clues. Let's actually zoom in on one of those key tools for a second: descriptive statistics. Think of these as the detective's field notes. They're just quick summaries that describe the most important features of the data. It helps the investigator get a fast, accurate read on the situation without getting bogged down. So what kind of clues do these stats actually give us? Well, the mean, or the average, gives the detective a sense of the usual suspect, the typical value you'd expect to see. The range, on the other hand, shows just how much the evidence varies. Is everything pretty much the same, or are there some wild outliers that could be the key to cracking the whole case? These simple numbers give the first hints of the story the data is trying to tell. Okay, that's enough theory. Let's see how all this detective work actually plays out in the real world, with a pretty famous case study. I like to call this one the Pop-Tart mystery. It is a classic example of EDA just cracking a case wide open. So our client is Walmart, one of the biggest retailers on the entire planet, and they collect a truly mind-boggling amount of sales data every single day. Their challenge to their data detectives was pretty simple: go find the hidden insights in all this data that can help us grow the business. So a data analyst at Walmart started digging. They began their exploratory data analysis, just sifting through millions and millions of transactions. And here's the key. They weren't looking for anything specific at first. They were just exploring, looking for weird patterns, strange connections, or, anything that just didn't quite seem right. And in the middle of that investigation, they found something truly bizarre. A wild, totally unexpected spike in sales for one very specific product, but only under very specific circumstances. Sales of this one item shot up 7-fold, a massive outlier that basically screamed for attention. And the clue was as strange as it was brilliant. Sales of strawberry Pop-Tarts jumped by 7 times right before a hurricane hit.
I mean, what's the connection there? Who knows? Maybe it's an easy, non-perishable comfort food. But the point is, no human would have ever just guessed that. But the EDA process, it uncovered it, plain as day.
And here's the most important part. What they did next. Walmart realized they didn't need to know why people bought Pop-Tarts before a strong. They just needed to know that they did. So they used this amazing insight to stock their shelves with strawberry Pop-Tarts right before major weather events, turning a totally strange data pattern into a real-world, profitable business strategy.
Now, the Pop-Tart mystery is a fun example for sure, but it really gets at the deep importance of this initial investigative work. Finding these kinds of clues is what allows organizations to make truly smart, data-driven decisions that go way beyond just a simple gut feeling.
So, what does all this detective work really get you? Well, it lets you spot anomalies, just like that Pop-Tart spike. It helps you understand the underlying structure of your data, find the most important variables to focus on, and test your initial hunches before you commit to a full-blown, expensive investigation. It's really all about getting to know your evidence inside and out.
You know, if there's one single thing to take away from all of this, it's this idea right here. Exploratory data analysis is like writing the first draft of your data story. It's where you discover the characters, the surprising plot twists, and the motivations before you even try to write the final chapter with some kind of predictive model. Think about it. From the movies Netflix recommends to you, to the route that Google Maps suggests when you're stuck in traffic, these hidden patterns are absolutely everywhere, shaping our daily lives. So the real question is, what other unexpected connections, what other Pop-Tart mysteries are just waiting to be discovered in the data all around us?